Hi everyone, in this video we're looking at logarithms, and essentially logarithms are a base of or a set of rules that allow us to write numbers in different forms, and we have some important things that or jargon I suppose, that we need to know, or terms, however you want to say. So b is our base, so that's the number that's being taken to a power, and then p is our logarithm, or another way of thinking about it is our power when you're in index form, and then q is the number that we want to take the logarithm of. And this relationship between index form and logarithm form holds for all the numbers that we're working with. So logarithms do become important as we move on through maths, and it'll become apparent how important they are as you do more problems that involve logarithms. But for now, we'll just look at applying these formulas and see how they work. So when we're using these formulas up here with this example that we're looking at, it's important to identify b, p, and q. So b for this one, our base, is 3, and q, our number, is equal to 81, and p, what we want to work out a logarithm of, is going to be 4. And so now substituting those into this formula for log, we can say that 3 to the power of 4 equaling 81 is equivalent to saying log of base 3 of 81 is equal to 4. So that's our relationship between those two different ways of writing those equations. Okay, so over here, working out the following. So once again, we want to identify what b, p, and q are. So for our first one, our b is going to be 5, and our p is what it's going to be equal to. So I guess we could say p we don't know yet, and then q is what we're taking the log of. And we don't need two q's, we just need the one. So q equals 125. Okay, so writing that into index form, we would have 5 to the power of something equals 125. And so here we know that 5 to the power of that something, or maybe we could write 5 to the power of p. We know that that p would have to be cubed, so p would be equal to 3. Okay, so let's look at question B. So for question B, our base would be 10, and our q would be 100. And so we're saying 10 to the power of p equals 100. So 10 squared is 100, so p would be equal to 2. Okay, moving on. Our next one's asking us to solve. So for this one, b is equal to 3, and q is equal to x, and p is equal to 2. So we could write this as 3 squared equals x, and so x would equal 9. And in our last example, our b is equal to p, so a little bit of a confusing work with numbers here. Our q is equal to 64, and our p is equal to 6. So we would have p to the power of 6 equals 64, and so we're trying to think of what the 6th root of 64 is, and you can probably guess there's only one real number that could work with that, and that is 2. So basically, when we're starting out with logarithms, it's all about being able to interchange between these different forms of writing equations, and if you can get used to that, you should be fine. So your work is exercise 19.01 on page 286. Thank you.